Solve each of the following linear systems using substitution. Check the solution. Alright, so as the name states, substitution, we're going to use a substitution to solve this system of equations, rather than maybe graphing. So if we look at this system, we have 5x minus 3y equals 9, and y equals x minus 1. Notice how in the second equation, we have the y variable is isolated. Once we have an isolated variable, we will use substitution to replace the y, in this case, the y in the other equation. So I'm going to use the x minus 1 to replace the y in the other equation. So we replace in the other equation. And so that would give me 5x minus 3 times y is equal to 9. Well, instead of y, we're going to replace that with x minus 1. Notice how I've used parentheses because I need to distribute that negative 3 through the entire value of y, which in this case is x minus 1. So then that would give me 5x minus 3x plus 3 is equal to 9 by applying the distributive property. Combining like terms yields 2x plus 3 is equal to 9. Now I will subtract 3 from both sides. And 2x equals 6. And I'll divide through by 2. And x equals 3. We were asked to solve the system. Well, remember, a system of equations has as its solution an ordered pair, so we now need a y value. Well, if we recall from the very beginning, we know that y is equal to x minus 1. So then by substitution again, we have y is equal to 3 minus 1, y equals 2. So we think, from this point, we think that the solution is the ordered pair 3, 2. Let's check our work. Is 5 times 3 minus 3 times 2 equal to 9? 15 minus 6 does equal 9. That checks out. Let's check in the second equation. Is 2 equal to 3 minus 1? Yes, it is. So we can be confident in our solution at 3, 2. Now we have negative 4x plus 5y equals 10, and y is equal to 3/5 x. Again, notice that the y variable in the second equation is isolated. So I'm going to take the 3/5 x and use it to replace the y in the other equation, yielding negative 4x plus 5 times y is equal to 10, replacing the y with 3/5 x. Don't need to use the distributive property because there's no addition or subtraction in the quantity. I'll just use multiplication. So I have negative 4x. 5 times 3/5, we can reduce out the 5s. That would leave a 3x. It's 10. So negative 4x plus 3x is negative x, is 10, and dividing through by negative 1, x is negative 10. We have the x value. Let's find the y value by remembering that y is equal to 3/5 x. So then y would equal 3/5 of negative 10. Going through the arithmetic here, I can reduce, thinking of that negative 10 as a negative 10 over 1, reducing between the 5 and the 10 leaves a 2, a 1 and a 2. And so then y would equal negative 6. So I'm hoping that the solution is -10, -6. Let's check our work. Is -4 times -10 plus 5 times -6 equal to 10? Let's see, that would give me 40 plus -30, which is equal to 10. That checks out. And let's see, is -6 equal to 3/5 of -10? And we actually just went through that arithmetic, and so that does check out. So the solution is -10, -6. 2x minus 4y is equal to 4. X minus 3y is equal to 1. So notice we don't have any of the variables isolated in this situation. But in the second equation, that variable x is easy to isolate. And so what I will do here is I'll just add 3y to both sides. And that would give me equivalently x is equal to 3y plus 1. So now the x variable is isolated, and I will use the 3y plus 1 to substitute for x in the other equation, yielding 2 times x minus 4y equals 4, and I'm replacing the x with 3y plus 1. Applying the distributive property, 6y plus 2 minus 4y is 4. Combining like terms, 2y plus 2 is 4. Subtracting 2 from both sides, 2y is equal to 2. Dividing by 2, y is equal to 1. Let's find the value for x. Recall that we found that x was equal to 3y plus 1, making the appropriate substitution. X is 1. So then x would equal 3 plus 1, and so x would equal 4. So we're thinking that the solution then is the ordered pair 4, 1. Remember, we usually go in alphabetical order, so it would be x comma y. Let's check our work. Is 2 times 4 minus 4 times 1 equal to 4? That would be 8 minus 4, which does equal 4. That checks out. And the second original equation is 4 minus 3 times 1 equal to 1. So that would be 4 minus 3, and that does equal 1. That checks out. So the solution is 4, 1.